Okay, in this video, we're going to start to talk about how to implement stacks using arrays. This is a little bit different than what the Zybook explains, since the Zybook does linked lists, and we will have a video explaining stacks as linked lists later on, probably next week. But for now, I'm going to show you how to implement them using arrays. Conceptually, they should both be very similar, but I know some people will understand arrays a little bit better than linked lists, so at least you have been exposed to both. So remember that a stack is a data structure that stores a collection of elements. It allows for the major things are push and pop, which allow you to put something on the top of the stack or take something off the very top. And notice that you don't have access to anything other than the top of the array, or the top of this stack, right? We usually have a couple methods that help us in maintaining the stack. The first one tells us if it's empty or not. The second tells us how many things are in the stack, right? So if get length is 0, then is empty is true, right? Those sort of work off each other. And then peek allows us to take a look at the very first element without actually taking it out of the stack. This isn't always accessible or isn't always available. And actually some of these are quite often not implemented unless you actually really need them. And there's some others, and we'll get to one later on, that you might use as well. So to implement a stack on an array, you assume that you have a stack class with some array A in it, right? And in addition, we have an integer here, we're going to call it top, that holds the index of the element after the top of our stack. So right now our stack is empty, right? So the element after the first element in the stack is 0, because there's nothing in the stack, right? And as we add stuff, right, this top pointer keeps getting pushed further and further, right? But top is always pointing to the index in the array that's just past the last element that we added, right? Similarly, we're going to decrement the counter. We're going to decrement top when we pop stuff off. So when we pop off 3, the top pointer goes down, pop off 2, right? And we end up here. So that helps us when we implement the other things that we might want to implement on a stack. For instance, if we want to implement peek, right? Peek is just the element that's at top minus 1, right? If it exists. So if top is 0, it doesn't exist. We can't run peek, as we saw in our example before, right? Peek is going to fail. So we would have to do something about that. So we would need to check if top minus 1 is still greater than 0. But in this case, top is 1, and top minus 1 points to this element here, right? Additionally, the way that we're storing this, the number of elements in the stack is exactly equal to the value of top. So the value of top here is 1, and there's 1 element in the stack. Going back to our explanation of is empty, right? So is empty is true when top is equal to 0, because that means that there's nothing left for us to take. So one of the peculiarities of using arrays for stacks is that arrays can be full, right? Something you don't have when you use, say, linked lists is we can actually run out of room in our array to add extra things. So we say that a stack is full when the top pointer points to or has a value greater than or equal to a.length, right? That means we're pointing here, which means we can't insert something there. There's nowhere to insert it. So this is sort of a special thing. So we might want to add a function, right? So stack dot full that tells us if something can be added. Right? And we would have to check that before we push anything, right? Your push Your push method might call on this stack is full just to make sure, just like your pop might call on is empty. Right. So we're going to go into some examples of how to actually implement stacks in class on Wednesday if we get time. So these two videos, the stacks in general and stacks using arrays, are going to be helpful in when we get to class on Wednesday.